Welcome to a new video. Today we'll be taking a look at a device which I believe might make sense owning given the rather difficult times we're experiencing with the invasion of Ukraine by the Russian army. As you may know, Ukraine is home of several large nuclear power plants, several nuclear waste facilities, as well as the well-known Chernobyl site, which was recently disturbed by Russian forces digging trenches in the Forbidden Zone. And if that's not stupid enough, they're also shelling pretty close to other nuclear plants as well. So I looked around for a portable Geiger counter that might give some indication or warning if the radiation levels start to increase. And there are a few models available online, some which are for professional use, but of course you would expect those to be very expensive. So I was looking for something on the affordable side of things, let's say on around the $100 mark. And this model popped up in my searches. This is the JD3001 multifunctional Geiger counter, and this can monitor gamma, beta, as well as electric and magnetic fields. And it's all built into the same unit. I'm gonna put the specs of this unit on screen while I mention that it was offered for free by Banggood.com for the purpose of this review, and right now there is a high demand for these, but it does show on stock on Banggood.com and the price is discounted. And on top of that, if you look in the description of the video, you will find a coupon code that will provide you with an additional discount for this product. Not sure how relevant it is, but the unit also includes a temperature and humidity sensor, which is located in this small extremity. And when compared to other units available on the market, this one seemed more interesting because it had some nice features, like it has a built-in lithium battery, a rechargeable via USB Type-C port. It can do data logging on its internal memory, and then you can access and download the logs through the USB port. And probably the nicest feature is this rather nice and big color LCD display. Before we continue with the review of this unit, let me mention the sponsor of this video, PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. But you can get more than PCBs manufactured with PCBWay. They also do PCB assembly, injection molding, 3D printing, machining various parts, so you can have an entire prototype built using their services. Check out their website linked below. Now, although this enclosure feels pretty decent with the soft rubber overmolding, it's not in any way dustproof or waterproof, nor does it claim to do that, but I figured I'd mention that because there are these big vent holes on the back, so dust and moisture can easily get inside this meter. The unit came with a partially charged battery, so it was ready to use right away, and it seems to have quite a good battery life. There's no mention of that in the specifications, but judging by the battery indicator on the display, I've only charged it once when I got it, and I still have, it shows like a full battery after using it for a couple of days. Now, having that internal rechargeable battery sure is convenient and provides lots of battery life, but if you're thinking about the worst case apocalyptic scenario, maybe you would want one that uses AA batteries or something more standard. The display is quite bright and still visible under direct sunlight. Sure, it's not ideal, you'll get a bunch of reflections from this glossy finish, but I have used it outdoor in direct sunlight and it was still visible. I've also tried to capture a picture of that, but it shows much worse in the picture than it was in reality. And you basically have two operating modes on this unit, one which measures the nuclear radiation and another mode for measuring the electrical and magnetic fields, and you can switch between those using the plus key. So you don't really need the user manual, you can figure out how this thing works pretty quickly. On the nuclear radiation tab, there isn't much I can show you because there are no meaningful measurements happening right now. There's no nuclear radiation other than background in my lab, and I don't have any source of radiation to test this with. But what I would mention is that you get these three numerical displays as well as a graphical display which scrolls at the bottom of the screen. And on the electromagnetic radiation tab, I did get some interesting measurements while being close to some energy distribution lines in a field. I believe they were 400 kV lines, and standing in their vicinity got me these readings on the meter, which were around 500 volts per meter and 3.7 microteslas, but they varied a lot depending on my position and orientation of the meter. Bringing a strong neodymium magnet close to the meter will of course show some higher values for the magnetic field, and the meter will start beeping because it's over the threshold set for this measurement. The same way, bringing this meter close to a wire that is energized from the mains AC line, for example, should show some values for the electrical field like I have here. So by now I'm sure that all of you are wondering what type of radiation sensor this guy uses internally, because that will likely be its main use. So let's do a teardown and see what we got inside. We have 6 self-threaded screws that we need to remove, and that will grant us access to the inside of this meter. We can see the rather medium size, I would call, lithium polymer battery, which appears to be floating inside, but it is not. This is actually held together between these mounting posts and the back of the enclosure. And this little guy must be our Geiger detection tube. I have not seen any so small before, but I have not seen many in total, so I don't know how relevant that is, but I find it interesting how small the detection tube is. The main microcontroller inside the unit is a GD32F103, which seems like a smart choice because of the lower cost and presumably better availability during these chip shortages when compared to the original STM32. This inductor as well as this small PCB, I think, are part of the magnetic and electrical field pickup circuit. This little guy here looks like a flash memory chip, which might be used to do the data logging from the microcontroller. And I can't really see any markings on this small Geiger tube. I don't know if it's some older Soviet originating sensor or something newer, maybe made in China. But if you recognize this type of sensor, please let me know in the comments below. I do like how they use this standard like 5mm fuse holder to secure the sensor in position. That's a clever use of a bog standard component. I've also posted a picture of this sensor on my Twitter, and someone responded suggesting that this might be a J705 tube module, and sure enough, if you Google that part number, some Alibaba listings come up suggesting that this might actually be a Chinese made sensor. And another thing we noticed right next to the tube, because this tube needs to run on high voltage DC, we notice a multi-stage CW multiplier circuit, which uses diodes and capacitors to boost the voltage to probably something like 400 volts. We also have the temperature and humidity sensor, which is located on its own separate PCBs, and judging by the markings we have right here on the main PCB, it looks like an I2C sensor. And that's about all that's worth mentioning inside this meter. Plenty of processing power inside this microcontroller to do the readings, save the data, and drive the LCD at the same time. So it's a pretty good choice for this meter. So because of the popularity of this microcontroller, I would say that this is easily hackable to open source firmware. I think we even have a JTAG port here, so if someone feels like doing that, I think it should be possible. So even though I have nothing to compare against, I'm certainly not equipped to test accuracy on stuff like this, but it just feels like a decent meter. The menu system was easy enough to figure out without a user manual, and I haven't seen any errors or glitches while using it, and the internal construction is decent enough. In any case, I don't think anyone would use something like this to do any absolute measurements to get like absolute values out of this. You'd probably use it just to generally get a feeling of if something is wrong or not. So I can definitely recommend this model if you're in the market for a nuclear radiation detector, which as a bonus will also offer you temperature, humidity, as well as magnetic and electrical field measurements. But I would also like to hear your feedback in the comments below, so let me know if you own something like this, or if you're starting to consider getting one, at least in Europe, because of recent events. And if you would like to order this particular model, check out the link I've placed in the description below the video and use that discount coupon to get a better price. That was all for today. Thank you for watching this video, and if you enjoy these kind of videos, you can help support the channel with as little as 1% per month via Patreon, or you can just hit that like button, which is free but still helps a lot. And some bonus footage at the end of the video. I've only realized at the end of the video that I had the protection film on the LCD for the entire duration of this video. There isn't a big change in display brightness or anything like that. It's still a glossy display even with the film removed.